Hey guys, Wages World here. I'll do a video for you. We've had quite a bit going on. I'm just going to jump into this and let you guys see some stuff. And this is some of the observations that we're making, some of the stuff that's been going on. We had a CME and it's coming right at us. Okay, just to let you guys know. It should be here about the 11th. I'm not sure how big or how intense it's going to be yet. But the models are showing that it's coming right at us. And then right behind it, we have a solar wind stream that is supposed to be there. So with that being said, this right here, Scott did a video on the CME, and I'm going to show you some captures of it also. But anyway, he did this graphic because we get a lot of questions on this. Now, when our object is in certain positions, okay, it causes the sun to have CMEs, right? That's what we've been postulating for a while now. And it usually lights up our object. Okay, so why should this be any different? The only difference is that it's in more of a straight line right now. It's usually when we see it, because of our positioning, it's off to the either that side or that side of the sun. Okay, but right now it's right out in front of us. Okay, it's actually, I think, judging by this, I think it's actually kind of to the north of us, so it would be in a position to like where the SDO wouldn't actually see it because it's zoomed in too far. It would be out of its perspective. But it's out in front right there, close enough that I do think that this is what's going on. I think that this object here is generated this CME, not to mention the sunspot, which I've been talking about for, I don't know, a week now. Guys, we got to pay attention. When the sunspot gets really close to Earth facing, what's going to happen? Well, we've lined up. You know, we all know that, you know, certain alignments cause more intense stuff to happen out in the cosmos, right? And this just kind of lends right to it. Now, to give a little bit of validity to what we're saying right here, you know, we've been able to say, hey, it's going to be in this position. We're going to have a CME here within a couple, 3 days of this timeline, and it's going to happen on this side of the sun. And for the past 8, 9, 10, 12 months, we've been able to say that, and it's happened. Okay? To me, that's not an accident. It just gives validity to what our observations are saying and what we've been kind of postulating with this 28-day orbit. And now I got something else to show you that I just came across. Okay? Now keep in mind, like I said, the position of that according to Earth right here. Now I'm going to show you a capture from Stereo A. This is from today. Right? Stereo A is over here. Earth is over here. So obviously I'm pointing to this. Okay, this is Stereo A. Stuff is very, very pixelated here. Okay, it's hard to get a good clean picture here. You're just not going to get one. Even if you upgrade it as far as you can to 4K or 8K or whatever you're doing, you're not going to get a good capture here as far as seeing a very detailed shape. But I will say this would be in the same position as where our object should be. Okay? Plus, if you look down in here, you start looking at this just a little closer. You know, a lot of times we just say, hey, these are cosmic rays. But usually when we see a cosmic ray, we see more than one on the same capture. And we're not seeing that. Okay? So that's just how the tool interprets a cosmic ray. We see these streaks or dots or what have you. And they're usually, you know, a bunch of them all at once. But this is just one thing here on the screen, guys. And then, you know, the lighting of it is correct. What do I mean by that? Well, it's lit up on this side and it's darker over here on this side of it. Okay, because the sun's over here, shining like this way. All right, not to mention, like I just said, guys, that CME fired right off that direction. Okay, so I'm showing you all this because, you know, it needs to be shown, it needs to be said, it's here. This is the observations that we're making. You know, and everything's falling into, you know, when we're able to say, hey, there's going to be a CME here on this day, or hey, or not just that day, just give like a small time frame, because you can never really say exactly what day. So I'm just saying that. Now, something else I'm going to show you guys here. Again, just keep that in mind, guys. That right there. So what I'm going to do is I'm going to take you over to LASCO and show you guys the actual CME itself. Okay, guys, this is over at ISWA. This is LASCO C2. And again, this is the red view. This is why we like the seed site, because it gives us a black and white version like Cactus does. But what you're going to see, and I'm going to zoom in here as far as I can. This is, well, first off, I guess I should do this. The Earth is here looking at the sun. Okay, that's our perspective from this satellite. All right, so the CME, it's coming right at us. What we're going to be able to see is the edge of it, because this right here is the occulter, and it blocks a lot of what we can see. Okay, if that occulter wasn't there, we wouldn't get a capture at all, because the camera would be just flooded with light. All right, it would be way overexposed, and we wouldn't see anything. So that's why we have to look at it this way. Now, again, you're going to see it. It's going to come out on this side. You're going to see it more. You can actually see it kind of coming on this side too. So, but it is coming right at us according to the models. All right. So I'm going to just kind of scroll through this for you. Okay. I'm not sure if you guys can see that or not. I know it's hard to see. It's right in here right now, and it kind of moves up that way a little bit. It's doing a little rocking motion there. And again, guys, I know it's hard to see. So you got that. Okay, and then it just zips right on out. Now, most of that came right at us. Okay, it was coming right directly at us. And if you remember the capture I just showed you, it would make sense that it's actually kind of going up this way a little bit, because that's where our object is, I think. So, and if you look on the other side, you can actually kind of see it, the CME kind of popping out there on the end on the other side. You can see it getting a little bit more bright and more bold. See that? And I'm sorry this is hard to see, it just is. I wish this was obviously on the seed site, because we would have such a better picture of this. And why can't we see it on the seed site? Well, let me show you. Okay, guys, this is seeds. I take you guys here all the time. Okay, I'm going to give the people that are new, I'm going to give you kind of just a little a view of what we would be looking at. Okay, this is seeds. Now the capture I just showed you on just before this was this. Okay, but what we're seeing is the exact same thing, just in a different format on the left side. The left side there is a CME detector. Okay, it's there to to catch CMEs and give us some sort of an early warning type of thing. It outlines it and all that kind of a thing. That's why we like to see it here. We also were able to get a more detailed capture of it, and we see our object on this particular tool a lot. Okay, when we have those CMEs and it lights it up. So as we're looking at this, I just want to give everybody a perspective there. Okay, especially the new people. Now you got the Earth is here again, and it's looking this way. So that is our perspective. So what am I going to talk about? You know, what's going on with seeds? Well, if you remember my last video, I was showing you guys we had a crack in our magnetic field, and we seen what from that? We had particles were able to get in, and it introduced auroras that were actually pretty intense. Now, they didn't come down to mid-latitudes or nothing, but I seen some great captures of the aurora photographers, man. They were beautiful. But the fact of the matter is, they came in unexpectedly because we had a crack in our magnetic field. It opened up. All right, and I showed you guys that in my last video. Well, what's interesting is that same day, we get no data from seeds. Now, one day, whatever, I don't care, right? And we can go to the monthly calendar, and the monthly calendar isn't even giving us that data right now. Usually, if you don't see it here, you can go to the monthly calendar and you're able to get it. It's not there. Okay? So, that happened with the crack in the magnetic field. Well, the next day, we had, guess what? An unexpected solar wind stream that almost took us up into storm levels. We took some pretty good hits on our magnetosphere. It got up to 842 kilometers per second. That translates to 1.9 million miles per hour, close to it. Okay? but yet we don't get to see any data for that day, at least from the sun. Now, what I'm saying here, guys, and then the very next day, what do we see? CME. Okay? 3 events, totally unexpected, 2 of which caused auroras. The other one, which was a CME, obviously you can't ever predict a CME when it's actually going to pop off. You just can't, like to the hour, or even sometimes to the day. Even when we're talking about our 28-day orbit, there's usually a couple-day window there because of positioning. You know, the sun is going to react when the sun wants to react with something. You can't just say it's going to happen at this specific moment and all that kind of a thing. That's my point here. But we had three things that all compiled there, but yet we don't get no data here on seeds from it. Now, you know, if we're talking about magnetosphere cracks and stuff like that, you know, that's not going to be, we're not going to be able to see our magnetic field crack out on the sun. That's not what I'm saying. What I'm saying is there something else going on that caused those auroras? You know, are they not telling us something? Are we not seeing something that we should be? What's happening here? Because we get these 3 events, you know, just think of the odds of that, guys. Especially the first 2 events. Because they caused the same side effect, auroras. So what actually happened there? You know, chances are we're probably never going to know. You know, now, again, I do think that, you know, our 28-day orbit with the magnetic field of our object, when it reacts with the sun and stuff, it reacts with us too. Okay? I showed you guys in my previous video how our interplanetary magnetic field lines were broken. We weren't even connected to anything for very long periods of time. Hours. Okay? So, I mean, that shouldn't really be happening. And then, you know, like I showed you before, none of that stuff really actually should have been happening because we just didn't see anything coming. So, but yes, we had that CME, and I'm going to move on from this real quick, but I did want to point that out. And so, anyway, I'm going to take you to the CME tracker. Okay, guys, this is the CME tracker. Now, I'm going to give you guys a little bit of, positioning so we know what we're looking at. Okay? Now, this is a top-down view of our inner solar system. Okay? What you're seeing, guys, usually the square boxes or the diamond-shaped boxes, those are usually satellites. Okay? There is a key on here, if you see up here at the top. Now, Earth is the yellow dot, obviously, and Sun's the thing in the middle. Okay? Okay, and this is a top-down view. Now, this over here is a side view. So it gives you more of a directional because, I mean, this gives you a directional too, but we're talking about directional as far as left to right. Or east to west, if you want to say it in those terms. But the side view is actually giving you the north-south view of it. Okay? That's important because take in consideration where we think our object is right now. And I just, you know, if that was it on stereo A that I showed you guys, that little blip that was there, that little blip was right here. Okay, where did that CME fire off to? See that? Okay, so yeah, we'll just leave that at that. Now, this here is, what you're looking at here is our orbital line basically stretched out in a straight line. Now, I know that's hard to understand what I just said there, because this is a 2-dimensional model trying to represent a 3-dimensional thing. Okay, but if you go over here to the top-down view, you see our orbit right here. Earth's yellow, that stereo B is the blue, and stereo A is the red. So if you took our orbital line and you stretched it out into a straight line, Earth is here, stereo A here, I'm sorry, stereo B there, stereo A here. Well, that's what we see here. Okay, that's exactly what you're seeing. That middle line is the orbital line. Now, why is that important? Because You see the disruption right there. Watch. See that? That's the CME reaching Earth. Okay? So that's telling you, yes, we are going to take it. And you can go over here and look at the date. When that happened, it was on the 11th. So, and this thing doesn't even activate or even update unless it sees a CME. So if we don't have a CME for multiple weeks, we won't get an update on what this thing actually looks like. All right. Now, if you're wanting to know what these other lines are, that's our connection to the sun. You know, the sun connects to everything, guys. Okay, satellites included. Just letting you know. But there you go. That's what that is. So you guys can clearly see, you know, judging by this, look at this. And, you know, our object should be about right here. You know, it's probably closer to the sun. But it's in that direction is what I'm saying. So is that what causes CME? You know, you guys make up your own mind on that. But I actually kind of think that that's what happened here. Okay? Just like when we catch it, when it does it on the side and it lights it up. So, yeah. So given all that information I just gave you guys, I'm going to kind of break it down into just a little bit of a summary here. Okay. Back on the 4th into the 5th, we had a crack in our magnetic field that was unexpected. What did it do? It caused auroras. Let charged particles in. Side effect of that, auroras. Unexpectedly. The next day, we had an unexpected solar wind stream that almost bumped us up into storm level. What was the side effect of that? Auroras. And then the very next day, we have a CME. Now, I would challenge you guys to actually say that out loud by yourself and see what that sounds like to you. If that actually sounds like something that the odds wouldn't just be astronomically crazy that all happened in that pattern, you know, and also with, like I just said a minute ago, that graphic, hold on a second here. Here's that graphic that Scott made, okay? I am going to leave the link to his video also on this. But yeah, that shows you where we think this is. And it falls right in line, okay? So everything's happening right here on this 28-day orbit that we've been talking about. And everything seems, every observation that we're making is actually pointing to this. That this is something that, yeah, that is true. I don't know how else to say it. So, I mean, and again, I'm just showing you observation. And then that right there, when I seen that, because that is the exact position it should be in. Okay? And you can even see, because I zoomed in on this, you can see that, you know, here's the object, but if you look around it, it's disturbing this material right here. Okay? You got to look close, but it is. See how it's darker right around that area? Like this could be, you know, magnetics interacting with each other, or part of the CME itself is actually reaching that. And, you know, for the shadow to be on the right side, all of that. And, you know, if I put this in a filter, and I may later on show it to you tomorrow, I was looking at this. It's almost like there's something like that. But I'm not going to say there is. This is just so freaking highly pixelated. It's hard to get any kind of clear picture on stereo A, guys. Which is why we get so upset when Seeds is down. Because that gives us a more detailed pic. And I do think that they shut these things down and don't let us see stuff sometimes. I really do. I know that happens sometimes. 2012 was a great example of it. You know, when the magnetopoles reversed and went the other direction, not our magnetic poles, but the magnetopoles reversed, and they scrubbed all that data. You know, and there was those people like Scott and Terrell, Black Star, and others recorded some of that, and we were able to still, you know, see some of it. But the rest, as far as officially out there on their sites, they took that stuff off of there. Okay. So anyway, guys, we'll check the earthquakes real quick. All right, guys, this is the earthquake USGS. Obviously, most of you guys probably already know there was a 5.8 in Puerto Rico. Okay, It says it was doing some damage and stuff. Scott actually wrote an article on it over at his website, planetxnews.com or .org. I'm sorry. But then you see all the aftershocks. Look at all these. And it was swarming before this happened. There was actually foreshocks just all over the place over there. Look at all these. Okay. Is this related to the solar weather? I think it is. Okay. And then you get this 4.6 in Japan, which isn't that big of a deal. I mean, that happens all the time. But look at all these in Puerto Rico. Just the sheer amount of these things is crazy. And then we have this bigger one that happened. Okay, 4.9 in Puerto Rico. That just happened to, when did that happen? Well, about 12 hours ago. But I just seen one that was in Indonesia. Yep, 5.2. I mean, those are substantial ones, guys. I mean, they're not causing big problems yet. But then you got Papua New Guinea, 5.3. Okay, so there are earthquakes happening. And they are increasing in intensity since we started seeing these crazy stuff with the crack in the magnetic field and all that. So, yeah. All right, guys, I'll give you a little update on the Schumann here real quick, too. Look at this. I haven't seen quiet conditions like that in a very long time. But look what happened when we go quiet. You see how the signature that we've been talking about, that I was calling a code there for a minute, which I guess it still could be. I just don't know what that is, guys, and I've talked about that at length. I'm not going to go into that right now. But it showed up very, very prominently there, guys. That is just, look at that. If that is not a tool flaw, that is not natural. I'm just saying. That is most definitely done intelligently for a reason. And whatever that reason is, we can all postulate and theorize on what's going on with that. But as I said before, you look where it's at now. Okay? It's up here. Here's our base frequency, guys. And it started down here. So it's like it's migrated about halfway to our base frequency. And it's very, very prominent right now for some reason. You don't see that anywhere else on this, okay? And again, like I talked about before, are we getting multiple base frequencies right now? Something that's just going to become normal? Because we do see, signatures just hanging around that don't go away anymore. Okay? It looks as though as we're getting ready to pick back up in some activity here on the end of this. But that is a pretty decent amount of time that conditions were pretty normal. Okay, it's been a long time since I've seen that, to be honest with you. It usually looks like this, at the very least. Okay, so take that for what it's worth. It really should be looking more like this, just so you guys know, for normal conditions. Because that 7.83 hertz is right there, and that's definitely there. Okay, so I'm going to leave you with this, guys. Okay, I caught that right there. Not sure if it's actually what this is showing it to be, maybe. It would be in the correct position for it to be that. And again, we have to keep in mind that whatever this object is, whatever that is, if it is an object, it's way bigger than the Earth. Okay, I want to put that straight up and out, because you see the white circle, like I said, if you compare those two to size right there, the Earth is way smaller than that. Okay, and this really would be about the size probably of our object, or at least one of its companions. Okay, so yeah, guys, I don't know, man. I just don't know what else to say about this. So, just to get a little bit of another summary here, we got magnetic field crack, solar wind stream that was not expected the very next day, and then a CME the day after. Run that through your brain. If you think that that's actually not odd for all that to happen, that's cool. I'm good with that. But for me, I think the odds are way against that. So, but anyway, guys, God bless. Yeshua saves, and you can still drink this Kool-Aid.